In this video, we generate the trend line and polynomial of hyperbolic cosine, hyperbolic sine using the Taylor-Maclaurin series sum in gamma function. We begin with the hyperbolic cosine, which is ARRAY formula, hyperbolic cosine of the x values, and the hyperbolic sine, which is ARRAY formula, hyperbolic sine of the x values, and the Taylor-Maclaurin series sum, which is the summation of a times x to the power 2n plus k, where the value of k is 0 or 1. So data validation, list of items 0 or 1. You can start from 0 if it is hyperbolic cosine, 1 if it is hyperbolic sine, and the value of n is from 0 to infinity. So 16 is good enough. Now we calculate the coefficient, which is equal to ARRAY formula 1 over gamma 2n plus k, so 2 times n plus k plus 1, and enter. Now we can calculate the expansion. ARRAY formula, series sum of the x values raised to the power 2n plus k, so x raised to the power 2n plus k. 2n plus k starts from k, incremented by, that's 2n, 2, 4, 6, 8, so the increment is 2, and the coefficient will be this range, 8. And we'll chart this. Insert chart, and we use scatter chart. We remove the title because we're going to use the equation as label. So for the trend line, we use polynomial to the 8th degree, and for the label, use the equation. For the legend, position at the bottom. Going back to the setup, column A is label. Now to customize for the series, we don't have a yellow. So change that to green. Change this to green. And put the point size, all series, point size maximum, except for the expansion, the point size none, but its line thickness maximum. So here we have the trend line and polynomial of cosine and hyperbolic, the hyperbolic cosine and hyperbolic sine. We'll calculate this polynomial regression coefficient using Linest. To do that, we use the Linest matrix. So we complete the Linest matrix, starting with the power. This is transpose 0 to 8. And the elements of the matrix, ARRAY formula of the x values raised to the power 0 to 8. Now we can use Linest. Linest for the hyperbolic cosine, that's data y and data x. For the expansion, Linest data y and data x, and the hyperbolic sine, Linest data y and data x, and enter. Now we can toggle this, so let's compare So coefficient of x to the 0, 1, 1, 0. Coefficient of x, 0, 0, 1. So 0, 0, 1. Coefficient of x squared, 0.5, 0.5, 0. Coefficient of x cubed, 0, 0, 0.167. Coefficient of x to the 4th, 0.0417, 0.0417, 0. Coefficient of x to the 5th, 0, 0, 8.23 times 10 to the minus 3. Coefficient of x to the 6th, 1.38 times 10 to the minus 3, 1.38 times 10 to the minus 3, 0. Coefficient of x to the 7th, 0, 0, 2.2 times 10 to the minus 4. Coefficient of x to the 8th, 2.7 times 10 to the minus 5, 0. And we toggle this to 1. So this time, this approximates the hyperbolic sign. Toggle it to 0. This expansion approximate hyperbolic cosine. So we continue with 1. So coefficient of x to the 0, 1, 0, 0. Coefficient of x cubed, x, 0, 1, 1. Coefficient of x squared, 0.5, 0, 0. Coefficient of x cubed, 0, 0.167, 0.167. X to the 4th, 0.0417, 0, 0. X to the 5th, 0, 8.28 times 10 to the minus 3. X to the 6, 1.38 times 10 to the minus 3, 0, 0. X to the 7, 0, 2.2 times 10 to the minus 4, 2.2 times 10 to the minus 4. X to the 8, 2.7 times 10 to the minus 3, 0, 0. This completes the use of the Taylor-Maclaurin series sum function, Linest polynomial regression, to generate a trend line and trend polynomials of hyperbolic cosine, hyperbolic sine using the gamma function.